Today, my name is Musisai, and I'll be inquiring about the exam regrade. Uh, right now, I might be frozen for you guys, but let me go back on my tab real quick. Okay, let's go to slideshow. All right, the exam I want to regrade is exam 2, and this is version A. To start it off with question 15, which is a PCR amplification question. Which pair of primers, 5 to 3 directionality, will correctly amplify the gene region in the wild type pink plants? Primer 1 and primer 2. This is asking about the pair of primers called the forward and reverse primers, and I'll be discussing why my answer is now A, and my initial points was 0 out of 2. The reason why this answer is A is because we got to look at the first primer, which is the forward one. The forward one directly just complements the first 5 nucleotide bases of the 3 to 5 directionality, which is just the top frame right here, GAATC. This automatically cancels out B and C as the first primer doesn't have GAATC as CTTHZ, which does not complement the 3 to 5 right here, and the TTAAG, which also doesn't complement the 3 to 5 right here. And then going on to the more trickier one, which is the reverse primer. The reverse primer focuses on the last 5 nucleotide bases of uh, the 5 to 3 directionality strand, which is CTTAA, which uses a method of reverse complementation. So first we complement it, which is just GAATT, and then we reverse it, which is just TTAAG, which gives us the primer 2 right here, which is 5 TTAAG3. The reason why it's reversed is because this strand is 5 to 3, and then all primers code 5 to 3, which gives us TTAAG. And this automatically cancels out answer D as well, since it's complementing the bottom strand of the 3 to 5, which is what we not want to do since we already have that complemented. Anyways, going back to question 2 now. This one is asking about the haplotype of the female parent, which is a phenotypically wild type. All right, so this is a kind of a tricky one since it doesn't follow the 9 to 3 to 1 test cross. In this problem, the two most represented progeny are the black body only and cinnabar only, which is 239, 211, instead of the wild type and the black cinnabar. And the female, which has the wild type, gets this BC from the BBCC right here, and then the capital B lower c from the BB lowercase c, automatically canceling out answer A, which is capital B, capital B, capital O, capital, since there is no capital C and there's no capital B, and canceling out answer D as well, since there is no uppercase C, which we could see right here, which leaves us the B and C, and my answer is B, since when you write this orientation out, it gives you this orientation instead of this one for some reason, since all heterozygous ones come first. Next, for our last one, we have question 23. Which of these genes demonstrate epistasis? Select all that are true. Epistasis is overall the masking of a gene, which can control the expression regardless of the genotype of the other gene, which does not follow Mendel's rules. And in the graphic for this problem, you could get 1 to 3 through gene A, and you could get 2 to 3 with gene B, and then 3 to 4 with gene D, which automatically cancels out answer C because there's no gene C, which leaves us the A, B, D, and E. And I'll let you know why it's not A and B. Like I said earlier, either A or B could give us 3, which means they cannot be epistatic to each other since they don't need each other. Meaning if there's AA, you will still get 3 because you could have a capital B. And if there's BB, you could still get 3 because there's a capital A, meaning that these two cancel out as well, which leaves us to D and E, which is my final answer, since D needs A to be, needs A to become to show its expression, and D needs B, since they are both the pillars to the genotype process, giving us D and E. They come first in other sense. And that is my video for now. Thank you guys for watching.